Okay, good afternoon, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing this afternoon will be the installation of my assembled 6-digit digital clock and a 9-volt voltage regulator to power it up. If we are just using battery here, the 9-volt battery required to power it up. If we try to use a battery, okay, just for the whole night, it will consume, it will be gone. So I think we should install a steady power supply of this coming from the outlet of our houses. But the requirement should be a 9-volt power input voltage. So what I did is that I installed a 9-volt voltage regulator, and this will now be the circuit diagram. This is the 9-volt regulator L7809. Terminal number 1 is the power, the voltage input. Terminal number 3 is the voltage output. The middle terminal is the ground. So if we try to power up the clock, we should be needing a 9-volt voltage regulator. The output should be 9 volts. We could not power up the clock by using a 12-volt power supply. It might burn out the controller IC. So we must have to follow the requirement for the power input voltage. It should be 9 volts. So what I did, I constructed a voltage regulator using an L7809. The output will be 9 volts. Okay. Regarding the power input, I got an adapter at the back. Okay. The power output of this one is 12 volts. So I will be using the power output of that one as an input to my voltage regulator. So if I will try to input 12 volts here, since this is an L7809, okay, with the circuit diagram, what will come out will be 9 volts. It is just approximately 9 volts, and that's the required for the so-called power requirement of the digital clock. So what I did now is I plug in the adapter with an output of 12 volts. Okay, that 12 volts goes to terminal number 1, the upper one. Okay, so the input voltage, if you try to measure it from ground to terminal number 1, it should be 12 volts. And the output of this voltage regulator, this is this 7809. The output is actually terminal number 3, the one at the bottom. So if we try to measure the voltage between terminal number 3 and the ground, it's 9 volts. And luckily, it really powers up the clock. And I now program the clock to be in the so-called military time. So right now, the time is 15, 16, and 37, meaning it's on the 15 hour, 16 minutes, and 41 seconds. If you try to convert this to the 12-hour format, you just subtract 12 from that 15. So meaning to say, the equivalent of this one in the so-called 12-hour format will be 3:16, 59 seconds. It's 3:17 in the afternoon. But militarily speaking, in the 24-hour format, it's 15 hours, 17 minutes, and 11 seconds. Same as the one I got, because I got another digital clock, right? But this is powered by just a 3-volt battery, because the IC being used here is just very small. Where is it? It's very small. So the requirement for this one is just 3 volts, but for this one, it's a bigger one, and the required thing is 9 volts. So as you can see it now, This is 15:17 military time, minus 12. That's 3:17 p.m. in the afternoon, same as the 6-digit digital clock, in which I power it up using a 9-volt voltage regulator by taking the output voltage of an adapter, which is 12 volts. I make that as an input, and the output will be 9 volts using an 7809 voltage regulator. Okay, that's it, guys. This is a knowledge know-how on how to assemble a digital clock, 6-digit format, and it is being powered by a 9-volt voltage regulator using an L7809 voltage regulator. So, as long as the utility line is not brown out or off, this clock will be on. Okay? Not unlike by using the 9-volt battery, it is just good for one night and that's it. That's why I make the option of making a voltage source of this one by using an L7809 voltage regulator. Okay, that's it, guys. So while I am working on my table, okay, I got my digital clocks. I got my equipment here. Equipment, plural. The plural of equipment is just without S. It is just. So right now, I am in front of my troubleshooting table, and I just installed my assembled 6-digit digital clock, and installing also a 9-volt voltage regulator to power it up. So actually, guys, I got two digital clocks, the one with the 6-digit format and the 4-digit format. The 4-digit format, it is just powered by a 3-volt battery. Okay. Because the IC used is just a very small one, the current consumption of this one is milliamperes. But the other one, the IC is a bigger one. Okay? I think it's a 16-pin IC controlling the 6-digit clock. So it consumes much greater current than the 4-digit format. Okay, good afternoon from Los Angeles. This is Professor David J. De Los Cruz, who have discussed the installation of the 6-digit format clock, powering it up by a 9-volt voltage regulator by taking the output of the an adapter, which is 12 volt. Okay, 12 volt input, the output of the voltage regulator will be 9 volts. That 9 volts will power up the 6-digit clock. Okay, good afternoon from Los Angeles. This is Professor David J. De Los Reyes.